Okay, so we did 2.2 part 1 yesterday. We're going to look at part 2. So we're going to do a little bit more with unit circle trick. Can someone remind me from yesterday, what are the 4 angles that we were able to get the coordinates for? You don't have to tell me the coordinate. I just want to know the angles, yep?
0, 90, 180, 270.
0, 90, 180, and 270. And all of those coordinates had zeros, ones, or negative ones. Okay, so, but they all had a 0. Today we're going to look at, just in the first quadrant, how do you find the coordinate for 45, 30, and 60. We're going to look at those 3. And if you look at it, they're not quite equally spaced. 30, 45, and 60 are kind of grouped together towards the middle. To be equally spaced, we need to do 2 other ones. We're not going to do these 2. But does anyone have a guess if this is 30, this is 45, and that's 60, what those other 2 would be? Yep.
15 and 75.
Right, 15 and 75. So to have everything spaced equally, you'd have to be doing the 15, which is right there, and the 75, which was right there. So we're gonna skip those 2. But those are the 3 we're gonna focus on. Right, so first thing we have to figure out is what's the coordinate for each one of these. And then once we have that coordinate, we want to write it down because we don't want to have to go through and figure it out again. Once we know it, it stays the same all the time. So in radians, just in case we see them pop up in radians, can anybody tell me what any one of those numbers is in radians? All right, Cameron, how do I convert degrees to radians?
Multiply by, 180 goes to the bottom, right?
Yeah.
And then it's pi on top.
Pi goes to the top. All right, so now we're going to convert it and see what it is. What can 30 and 180 be reduced by? Yeah. 30. 30 goes into itself once. How many times does 30 go into 180? 6. So 30 degrees is pi over 6. So what's the relationship between 30 and 60 if you compare the 2 of them? Yeah, what? 60 is double that. Because 60 is double 30. So if you double pi over 6, what do you get? Well, 2 pi over 12 is the same as pi over 6. Because that would just reduce.
So it would be 2 pi over 6.
2 pi over 6, which reduces to pi over what? 3. Yeah. So 60 is pi over 3. And 45 is pi over 4. So we do some problems. You might see pi over 6, pi over 4, and pi over 3. You might see 30, 45, 60. Depends on the problem. But we're gonna start with the 45 degree angle. So we'll do that first, then we'll come back to 30, 60. All right, so to figure out what the coordinate is for 45 degrees, we're going to draw this diagram. Now, first let's just think, why Why do we even need the coordinate? Let's see. If I asked you to do a problem like this, find the 6 trig functions for 45 degrees, what's the first thing you have to know to do that problem?
Coordinates.
You have to have the coordinate. So that's why we're going to figure it out, and then once we have it, we'll never have to figure it out again. All right, so let's go back up, see if we can figure out the coordinate. All right, so we know that this is 0. That's 90. So 45 is halfway between the two. So I'm going to draw my 45 degree angle right here. There's my initial side. There's my terminal side. I'm going to modify it a little bit, but I'm going to label something first. Look at the terminal side. How long is the terminal side there?
1 radian.
Well, radian would be measuring an angle, not a length.
Would it be 1?
1. Because we're doing everything on a unit circle. So the distance from the center to the edge is 1. Now, what I'm going to do is go like this. I'm going to draw a vertical. And I'm going to put it right there. And by putting it right there, what did I just make?
A right triangle.
I made a right triangle. So there's a 90. Here's the bottom side of the triangle. Here's the height of the triangle. Our goal is to figure out the coordinate for 45 degrees. Bless you. A coordinate has 2 parts to it. It has an x and a y. X tells you how far you move left and right. Y tells you up and down. If you go from the origin to the right and you stop there, that's your x. It's how far you move from the origin to the right. Your y is how far you move from that point to get up to that point. So basically the x and the y are the length of the bottom and the height of the triangle. That's your x and your y. Now I've got the same triangle, just a little bit bigger so you can see it better. I've labeled all my angles and the hypotenuse as 1. This side is x, and that's my y. But look at that triangle. It is a right triangle, but anybody tell me anything else about it?
Those 2 sides.
Right, it's isosceles. Because these 2 angles are the same, it means these 2 sides are the same. So we really only have to figure out one thing here. Once you know the length of the bottom, the height is the same, because it's an isosceles triangle. There's a formula we can use. As long as you know 2 sides of a triangle, you can find the third. We can use Pythagorean theorem. Yep. So let's use Pythagorean theorem. And let's solve for, remember, this side is really x. We don't have to use 2 different letters. Using 2 different letters would mean these are 2 different lengths. And they're not. So pick one letter, and we'll use that letter twice in the Pythagorean theorem. So Dominic, you mentioned that theorem. Can you remind me, what is that theorem? Okay. And can you use that theorem with our labels? And remember, we're going to use the same letter twice.
So it should be x squared.
Yep.
X squared.
X squared plus x squared.
Equals c squared.
And what's c in this case? Which is 1. All right. So let's solve that for x and see how long each side of the triangle is. X squared plus x squared gives me how many x squareds? Two of them. And we might as well just do 1 squared and get 1. Okay, what's my next step to get the x squared by itself? Divide by 2. So that's gone. So we get x squared equals a half. I'm just going to move it over here. Now, we don't want to know what x squared is. We want x. So how are we going to get rid of the exponent? What'd you say, Dustin? We're going to... Well, it's already squared. So we want the opposite. Square root. And when you square root it, that's how you do the left. And on the right, you have to do it like this. To square root a fraction, you have to do the top and the bottom. Okay, so that gives me x. What's the square root of the top? 1. And the square root of the bottom, well, we don't get a nice answer for that. So that is the length of each side of this triangle. But we don't want to write the length with a square root at the bottom. We want to fix that. So Sam, what would I multiply by to fix that so the square root goes to the top?
Square root of 2.
Yep.
Over square root of 2.
Square root of 2 over square root of 2. So at this point, we're done with the Pythagorean theorem. We're just taking the answer we got from the theorem and fixing it so the root isn't in the bottom. Okay, what's that going to give me when I multiply straight across? Square root of 2 over 2. And I don't know if you remember yesterday, but that was a number that came up in one of the problems we did. Okay, so now we can label each of these sides. The length of the bottom side from here to here is square root 2 over 2. And since the height is the same, because it's isosceles, the distance from here to here is also square root 2 over 2. So now let's erase the x and y and fill in the actual length. How long is the side that I label x? Square root 2 over 2. And how long is the side that we labeled y? Square root 2 over 2. There you go. So now that is always the coordinate for 45 degrees. If you forget it, you can figure it out again with the Pythagorean theorem. But it's a lot easier to just memorize it, so we don't have to figure that out again. All right, so there's our coordinate. Now, we could answer something like this. Find the 6 trig functions of 45 degrees. So I showed you this problem a few minutes ago, and I asked you, what do we need to do this problem? So I have the same question again. What do you need to figure this out? Which is the, right, we need the coordinate. Now, we have the coordinate. A 45-degree angle is always square root 2 over 2, comma, square root 2 over 2. And the easiest way is to memorize that. Now, from here, we did this problem in the notes yesterday. I didn't tell you necessarily it was a 45-degree angle. I just gave you this coordinate, and we already did it. But we'll go through it again, just to practice. All right, let's start with sine. Kiana, what letter is my sine? It's my y. And my y is root 2 over 2. Austin, what letter is my x?
Square root of 2 over 2.
That's good, yes. So cosine is the x, and it's square root 2 over 2. Tangent. Curtis, what's my formula for tangent?
Y over X.
Y over X, but in this case, the Y and the X are the same. So when we divide Y over X, what do you get? 1. Okay, so now we've got the 3 on the left. Tony, what am I going to do with each one of these to get the 3 on the right? You flip them. Which one of these would be the easiest to flip?
The tangent.
Yeah, let's just flip the tangent, get that one done. If you flip 1, what do you get? 1. Okay, so there's your cotangent. And Cameron, can you give me the first step to getting the cosecant?
2 over square root 2.
It's 2 over square root 2. Good. And the only problem with that is we can't leave the square root at the bottom. So Sam, what am I going to multiply by to fix it?
Square root 2.
Square root of 2. And now we're going to multiply straight across. 1, what's 2 times the square root of 2?
2 square root 2.
Just 2 square root of 2. And Jenna in the bottom, what's the square root of 2 times the square root of 2? 2. But then since you have a 2 in the top and a 2 in the bottom, it cancels. And the final answer, square root of 2. So Gavin, what's my secant going to be?
Would be, let's see, would be the same thing.
Same thing, yep. Because the sine and the cosine are the same. So when you flip them, you're still going to get the same thing. It's handy if you kind of remember, so you flip root 2 over 2, you get root 2. If you don't remember it, you can figure it out every time. But if you do it enough, you'll just remember that's what it is. Okay, so any question on a 45-degree angle? All right, let's take a look at this. I just want you to look at this for a second. This is 90. This is 180. Anybody know what number is exactly in the middle of 90 and 180? 135. Yep. If I draw my triangle like that and like that, how does that triangle compare to this one? Yep.
It's just reflected over the axis.
It's just reflected. So does the length of the side change when you reflect it? No. So the lengths are still the same. Root 2 over 2 and root 2 over 2. But the coordinate is not exactly the same as the coordinate for 45. Anyone think they know what the coordinate for 135 would be?
Would it just be
Okay, so what do you think it would be?
negative square root 2.
And what about the y?
It'd be the same thing.
That would be the same thing. So my point is, once you know how to do 45 degree, you can do a 45 degree in any quadrant. You should be able to do the 225, which would be down there, and the 315, which is over there. All of those have coordinates root 2 over 2, root 2 over 2. Sometimes they're positive, negative, or one of each. We're gonna look at that more tomorrow, but I'm just showing you kind of the 45 is important to know because it's used to do everything we're gonna do tomorrow. All right, so let's take a look at the other two angles I mentioned, the 30 and the 60. So those are 15 degrees away from the 45 on each side. Now, you'll see when we do the 30, 60, 90, it's not quite the same as 45, 45, 90. 45, 45 had two angles that were the same. These are different. Okay, so let's work through the 30, but then you'll see that work is going to be able to be used again for the 60. It's really the same thing. But we'll just focus on the 30 first. Yeah. Okay, so here's 0. Here's 90. 30 degrees is about 1/3 of the way through the quadrant. Right? 30, 60, 90. So the point is, try to draw the 30 so it's definitely less than half. So you always, to make your triangle, you draw a line from your point to the origin, and then straight down to the x-axis. There's my 9. Where's my 30 in that triangle? Which angle is it? The one on the left, or is it the one at the top?
The one at the top. Right now.
Yeah, the one that's more towards the bottom. That's the smaller angle. The way you can remember is the smaller angle is always across from the smaller side. But when you have a 30, 60, 90, all the angles are different, which means all the sides are different. This is the short side. In this case, that is the long side. I don't know, putting it in different colors makes it easier, but the bottom side is the long side, so it's going to be across from the big angle. 60. Okay, and it's a little small, so I get the same thing right here. Okay, now there's one side in that triangle that we already know. Anybody think they know one side yet? Yeah. How long is the hypotenuse? It's 1. Unfortunately, that 1 is not part of the coordinate. We're going to use it to get it, but it is not coordinate. Coordinate is going to be the length of the green side. That's how far to the right we go. And then the length of the red side. That's how far up. Now, I said all the angles are different. So what does that mean about the sides? They're all different. So what you can't do is this. Okay, just watch this part because you can't do this. If you call this side x and you call this side y, as you try to set up Pythagorean theorem, you're going to have this. X squared plus y squared equals 1. What's the problem with that?
You don't have a common area.
Right, we have 2 different variables. If we have 2 different variables, we're not going to be able to solve it. So what we have to do is figure out one of these first some other way. Then we can use Pythagorean theorem. But we got to figure out one of them a different way. Okay, let's take a look at that triangle. And I'm going to give you a hint how you can figure it out. You don't really have to use anything super clever. I should say it different. You have to be a little bit clever to figure it out. You don't have to use any really sophisticated math. So here's my hint. Just group all that together. And let's go like that. That's my hint. Anybody have a thought what we can do? Yeah?
You have to find like the outside angle. So like the 90-degree angle from the outside of that is 270.
We're going to focus more on sides here. So it's a good guess, but we're going to do something with sides eventually. But I've got to do something with these 2 shapes first. Anyone have a thought what we could do with the 2 of them?
On top of each other. Like
Put them on top of each other?
do like flip one and flip.
That.
Or like.
Flip it and make it a square.
Yeah.
Flip it and make it a square?
Yeah.
Okay, well, I'm being picky here. I can't really make it a square, but I can make it a rectangle. I'm not saying I know what to do with that, but.
Good enough. Now you got 2 sides.
Yeah, we definitely have a rectangle there. We got 4 90-degree angles and opposite sides are congruent. That proves it's a rectangle. Yep. I don't know what to do from there, though. I like the idea of putting the triangles together somehow, but let's not put them together to make a rectangle.
You can put it back to back.
Okay, which way?
Like 30s.
Put the 30s together? So if I want to put the 30s together, I'd have to flip it like...
And then it would be like 6.
Close enough.
Yeah, then it'll be 60.
So yeah, all the angles are now 60. That's a 60, that's a 60, that's a 60. So what does that mean about the triangle we just made?
It's equal.
Equilateral.
Yeah, equilateral.
So what does that mean?
All sides are the same.
All sides are the same. So we know this side is 1, this side is 1, but more importantly, that side is 1. And how does the side in red compare to the side in blue? How does the red and the blue side compare to each other?
They're equal.
Why?
They're the same length.
Yeah, they're the same length because those triangles are a mirror image of each other. So when you reflect something, the sides are always the same length as what you started with. So we know that this line segment is congruent to this line segment. Has to be. Because we flipped it to create it. So we have 2 line segments that are the same length, and they add up to give me 1. So how long must each one of them be?
2.
2?
100%.
100%.
That would be good.
Okay. Or we could go with this is where you step in and answer. 0.5. Yeah. We could go with 0.5 because they're equal and they add up to 1. So it has to be 0.5 and 0.5. So that's how you can figure out one of the other sides, just being a little bit clever. There's nothing super fancy like math there. But now we know this side is 1/2. So now the bottom triangle I don't need anymore. So I'm just gonna take that triangle, just move it, because we don't need it. Okay, let's call the bottom side x. What could I do now to get x that I couldn't do before? But why didn't we find that 1/2 a different way? We wanted to use something, but we couldn't. Now we can use Pythagorean theorem. How come we can use it now, but we couldn't before?
You wouldn't have 2 variables.
Right, I would have had 2 variables when I did it before, because I didn't know either side. Now I figured out one of them, being clever and kind of using a little geometry. I can figure out this third one using Pythagorean theorem. So, Tony, can you set that up for me using Pythagorean theorem?
It's 1x squared, or no, 1 squared
Okay.
minus 1.5 squared.
Let's set it up. Just set it up with your normal formula, and then we'll worry about moving things from side to side.
Okay. Then equals x squared.
Yep.
Plus 1/2 squared.
Okay. So there's your formula with Pythagorean theorem. And Dominic, 1 squared gives me how much? 1. Jackson, what about x squared? What about x squared? What does that come out to? We don't know x, no.
So this is x squared.
It's just x squared. And Dustin, what about 1/2 squared? Remember, that means 1/2 times 1/2.
0.5. Wait, no.
Well, 0.5 times 0.5.
That's 0.25.
0.25 or 1/4. Right. So Abigail, how can I get this 1/4 on the other side? Well, it's being added, so we can't get rid of addition with multiplication. What's the opposite of addition? So we have to use subtraction. And what would we subtract? We would subtract 1/4. So I'm going to go over here just because I don't have enough space. Nyasia, what's 1 minus 1/4? 3/4. And that's gone. So we get 3/4 equals x squared. So now we're one step away from knowing x. Tyler, how do I get rid of that exponent of 2? We're going to take the square root. Square root, square root, square root. So on the right, now we have x. And what about on the left? Square root 3/2. There we go. That's the length of the bottom side in that triangle. So this is root 3/2. And the y is 1/2. So now let's write the coordinate. 30 degrees. So the 30 degrees has an x, and then it has the y. How long is the side that we labeled x? Square root 3/2. Yep. And what about the y? 1/2. So root 3/2 is how far to the right you have to go from the origin. 1/2 is how far up you go. And that's always the coordinate for 30 degrees. Now, I know I said we don't normally use decimals, but I wanted to show you something with a decimal. If you take square root of 3 and divide by 2, you get about 0.86. 0.866. If you take 1 and divide by 2, you get 0.5. So which one is bigger? The square root of 3/2 is bigger. And if you look at your triangle, when you're dealing with a 30, 60, 90, the bigger side, which is we just said is square root 3/2, always goes opposite the bigger angle. The smaller side always goes opposite the smaller angle. That's how you can remember which one goes where. Big side, big angle. Small side goes across from the small angle. So then no matter which way I flip my 30, 60, 90 around, you should be able to label it. If you know this is the 30, and that's the 60. Short side, long side. Let's try it. How long is the short side always in a 30, 60, 90? Yep. It's always 1/2. And how long is the long side in a 30, 60, 90? Not the hypotenuse, the long leg. Square root of 3/2. It doesn't matter how you flip it, turn it, if you have that triangle all different ways. Always put the 1/2 across from the 30. Always put the root 3/2 across from the 60. So now that we know that, we can really figure out the 60-degree angle pretty easy. So here's your coordinate for 30. 60 would be more up there. Let me draw the triangle for 60. What's the difference between the triangle we drew for 30 and the one I just drew for 60?
other way.
Yeah, it's just standing up and then kind of flipped rather than being on the long side. It's standing up on the short side. So now, that's your short side. That is your long side. So how long is the short side? I'm just going to fix that so I have some space. So that side is 1/2. And what about the tall side? Square root 3 over 2. So all that happened with the long side and short side is they switched. So what's going to be the coordinate for 60? 1/2. Yeah. Square root 3 over 2. That's a lot to say. And all I do is I just remember those two numbers, 1/2 and root 3 over 2. I draw my triangle every time, and then I just look at which side is the short side. If that's whatever side is horizontal, that's the x. Whatever side is vertical, that's the y. So like say we had something like this. Let's draw a triangle right there. That would be 150 degrees. It's 30 degrees before 180. Which side is my short side in this one? The red one or the blue one? The red one. So how long would the short side be? It would be 1/2. The blue one is the long side. What number would that be? So it would be square root 3 over 2, and then when you write the coordinate, you have to write it as a negative because you went left, but the 1/2 would be a positive because you went up. So negative root 3 over 2, 1/2 would be the coordinate for 150. So all the triangles you could figure out that look like this, I could draw them like this, basically. They all have a 1/2 and a root 3 over 2. And then, I'm not going to draw it because it starts to look a little messy, but then you've got all the triangles that are standing up where the tall side, where the long side is the tall side, right, the height. This is the ones where the long side is the base and the short side is the height. So if you understand how to do the 30 and the 60, you're going to understand how to do everything we do tomorrow. So let's try the 30 and the 60. We'll do maybe the 30 together. I'll let you try the 60. Where is the 30? There's. Okay, so it says find the 6 trig functions for pi over 6. I talked about that earlier, so you might see it. So you've got to know which one that is. What's pi over 6? Yeah,
30.
That's your 30. Now, off the top of my head, I know the two numbers. I know there's a root 3 over 2, and I know there's a 1/2. I don't always remember which one goes where. Is the 1/2 first, or is it second? So what I do in my head is I draw it. I think about the circle. I think about 30 being less than half. And then I make a triangle. And when I do that, I can clearly see which side is the long and which side is the short. Here's my long side. That's my x. Here's my short side. That's the y. How long is the long side? Square root 3 over 2. That's going to be my x. And what about the short side? 1/2. That's going to be my y. So there's your coordinate. Root 3 over 2, comma, 1/2. You just got to get the order correct. All right, so now we've got the coordinate. From this point forward, there's nothing new. This is what we did yesterday. Just pretend like now that's what you were given. We'll find all the trig functions. Okay, let's start with sine. Gavin, what's my sign there?
Is it from the would it be 1/2?
Yep, sign is going to be the y, and this time the y coordinate is 1/2. So there's my sign. Good. Ryan, what about my cosine?
Square root of 3 over 2.
It's going to be my x, square root 3 over 2. Tyler, what's my formula for tangent?
Is it 1 over x?
It's y over x. Just imagine like putting a division sign right there. You're going to divide the two answers you just got, y over x. Tyler, when I divide them, what's going to cancel? The 2's. Don't cross the 2's out because they're part of your other answers. Just imagine crossing them out. So you'd be left with a 1 in the top, 2 would be gone, and a square root of 3 in the bottom. And that 2 would be gone. So you're left with 1 over the square root of 3. Can anyone fix that for me so I don't have the square root in the bottom?
Would you multiply both halves by square root of 3?
Yep, I'm going to multiply the top and the bottom by the square root of 3. And what's that going to give me when I do that?
Square root of 3 over 3.
Square root of 3 over 3. Okay, but while we're here, let's take care of the cotangent. Now, I'm just going to put a dotted blue box around that. What's in the dotted blue box and what's circled in black are the same thing, because there's an equal sign. You could flip either one of them. Which one is easier to flip to get the cotangent?
The first one.
The first one, right? The one with the dotted blue box around it. Because what happens when you flip it?
It's just
Right, square root goes to the top and you're done. If you want to flip the one that we circled in black, it's okay, you can. But then the square root goes to the bottom and you got to fix it again. All right, let's do cosecant. That one's going to be pretty easy. What's the cosecant of pi over 6? 2. You don't have to put 2 over 1. You can just say 2. And Cameron, for my secant, what's my first step? And then we'll fix it after. So it's 2 over the square root of 3. And can you tell me what you get when you fix it?
2 times square root of 3 over 3.
Yep, 2 square root of 3 over 3. Good. And there's your 6 trig functions for pi over 6, which is 30 degrees. So the way you'll see something like this on the test is each question is going to have 2 parts. I'm going to say something like find, and then I'll write this down. Find the sine of pi over 6. I'm not going to ask you for the cosine, the cosecant. So I'm not going to do all 6 in the same problem. Okay, maybe a different problem. But 1 trig function per problem. And I'd ask you for 2 things here. First thing I'd ask you for is, what's the coordinate for pi over 6? So you give me the root 3 over 2, 1/2. And then the second thing I'd ask you for is, what's the actual answer? You'd have to know it's the y value when you do the sum. Okay, so each question like that will have 2 parts. So something like this would be 6 separate problems on the test, doing all 6 of those. Okay, so there's the 30. Why don't you guys take like 2 minutes and see if you can figure out the trig functions for the 60. And then once we have the 30s and the 60s, I want to compare the answers and see what's going on. See if you can get the 6 trig functions for 60. All right, so let's start to take a look at it. And we'll start with the coordinate. What's the coordinate for 60 degrees?
1/2 and then square root of 3 over 2.
Yep, 60 degrees is closer towards the top of the circle. That makes the bottom side the short side. So that's 1/2. And the tall side is going to be your y. root 3 over 2. When you're dealing with 30s and 60s, it's always these two numbers. You just have to get them in the right spots. Okay, let's start with sign. Curtis, what's my sign going to be?
Square root of 3 over 2.
Yep. And Dominic, my cosine? 1/2. And Kiana, what's my formula for tangent? Yep, so it's going to be the square root of 3 over 2 divided by 1/2. So just imagine putting a division line there. And when you divide those, what we cancel? The 2's. So all you'd be left with is square root of 3 on the top and a 1 at the bottom. Okay, so there's my 3 on the left. And Jenna, what am I going to do with all of these to get the 3 on the right? Flip them. Let's do the secant just because that's an easy one. What's going to be the secant of 60? 2. You just flip that. No root to worry about there. All right, cosecant. Tony, can you tell me first step?
You flip it.
Okay, and when you flip it, what do you get?
Yeah. 2 over 3 cubed. Square root.
Square root?
3.
3. And then when you fix it so the root's not in the bottom, what do you get?
You get 2 times square root of 3 over 3.
Over 3, good. 2 square root of 3 over 3. So there's that one. And the tangent, well, we want to flip the square root of 3. We don't have anything there to make it a fraction, so we can just put it over 1 if that helps you, mentally. So how about Jackson? What's your first step when you flip that? What do you get?
Don't you just put 1 square root of 3? 1 over square root of 3?
Yep. And then when you fix that so the root's not in the bottom?
Square root of 3 over 3.
Perfect. And there's your 6 trig functions for 60. Now, if we go back to the 30 and look at those answers, you notice it's all the same answers for the 30 and the 60. But what ended up happening is they all switched places. The 1/2 and the root 3 over 2 switched. So the sine and the cosine switched. The cosecant and the secant switched. The 2 went from the cosecant to the secant, and the 2 root 3 over 3 went up to the cosecant. And the tangent and the cotangent flipped. So we had root 3 over 3 on the left. Now we've got root 3 over 3 on the right. So those are what switched places. Any question on getting the same answers with just different spots? All right. So those are the trig functions for 30 and 60. All right, so for tonight, there's a worksheet on Schoology. It has 10 questions. Each question is set up with 2 answers. The first thing I ask you for is the coordinate. And then the second thing I ask you for is one specific trig function. So then you have to know what to do with the coordinate. So I want you to do those 10 on the worksheet. And then these 5 are separate. They're not on the worksheet. And there might be a review problem or 2 in here from yesterday. There definitely is a couple review problems from yesterday. Okay, so tomorrow we will go over that, and then we will finish up unit circle trig. You will need a calculator tomorrow, so I will make sure I unlock the graphing calculators. Or if you have your own you'd rather use on the test, bring that tomorrow so you can practice using it. I will be after school tomorrow if anybody needs to make anything up and they have to do it outside of school hours.